Okay, good morning, everybody. Good morning. And hopefully we'll talk a little bit about autonomous vehicles, and we thought we would kind of focus on a little bit on the challenges, barriers, financing, things like that that are facing the autonomous vehicle development and deployment. I think we have a very exciting group here. Of course, if you notice, we're in the small room, not like the auditorium, so we're a little, well, one, we're a little closer, cozier. And I guess we'll call this is the, an interesting group to have to follow the last group, right? But I think we'll do just great there. So what I'd like to do then is kind of kick it off is that I'm your moderator. I'm Gary Miskell. I'm with Santa Clara Valley Transportation Authority. And I'm going to introduce the different panelists. I'll give them 5 or 6 minutes to kind of talk about kind of like their area that's important in this space. And then after we get through the whole panel, which is a bunch of us here, I'll then open it up for questions, and we can go and have a nice, lively dialogue with, kind of what's impacting and what's interesting to all of you that we can go for. And with that, I would also now like to, and just in case, I gave her, there's their picture. Of course, as you know, we take our pictures like 10 or 15 years ago. So if we look like that, just kind of get the gist, right? But this way gives you, now, I guess I should have put them in order. But anyway, I guess they are in order. Hey, that's a pretty good group, isn't it? All right. So let me start with, Amish Parashar. He is a partner and director of strategic business development and founding team member of the Yamaha Motors Ventures and the laboratory here in Silicon Valley. Amish has a variety of operating and entrepreneurial roles. He has several entrepreneurial residence and company founder. Most recently was a director of an innovation company, private company, and development lab. Amish is a frequent lecturer on complex technology innovation and has held teaching appointments at Stanford, Duluth, Singularity University, and UC San Diego. Amish earned 2 engineering degrees. Most of us just deal with 1, but he had to go work on 2. A AB from Duluth as well as a BE. And then also he has a MSc from the University of London. So that should be an interesting story. So with that, let me turn it over, give you 5 minutes,
I'm wondering if people standing in the back can close those 2 back doors. If I do that, we may not need the microphones.
I definitely won't need the microphone.
Oh, okay. The camera guy in the back is saying you have no choice.
What?
Yeah. Somebody did. Leave my coffee there. So thank you so much for having me and having us here. I'm happy to tell you a little bit about the way we're thinking about autonomous vehicles and some of the challenges. As most of you probably know, we are a vehicle OEM, sold between 7 and 8 million vehicles last year in 200 countries. Yamaha is known for vehicles that are mostly smaller than a car, and so I'm careful in speaking these days to not use the word car and not present ourselves as an automaker, because we aren't. We're very active in the automotive space, I think. We're engine suppliers to Toyota these days, in the past, Ford and Volvo and others. We have an interesting role in the general automotive space, but we're not a car maker. We do, however, make all sorts of vehicles that are smaller than cars. And I'm happy to talk about that. The interesting opportunities, however, tend not to be making more vehicles. And our intention here today and our intention here in the Valley is not to amplify our role as a global hardware maker. Right? Our intention is to understand what's changing in the world around us and present compelling solutions that are more than just vehicles. Right? If we continue on this path, the world will not be a place where we want to raise our kids or they want to raise their kids. I'll give you some simple examples. If you track GDP growth of developing countries, there comes a point where scooter and motorcycle ownership shifts to car ownership, right? And you can just think about an individual person generate some more income in their personal lives, decide to upgrade, so they upgrade from maybe a used motorcycle or scooter to a new motorcycle or scooter, and then they decide to upgrade one more time and they go to a compact car, right? And that kind of natural evolution happens so many times all over the world, right? And we've seen it and been a part of it for a long time. But now we're seeing for the first time, as GDP increases, people are not making that transition, right? The transition from small vehicles into automobiles is stopping. And the reason is several factors. One, congestion. Two, traffic and pollution. But three, and most importantly, is customer mindset, right? If you have a sharing economy, if you have things like community-owned vehicles or fleets that are accessible to individuals for individual use but aren't owned by individuals, it changes people's mentality for buying vehicles and especially cars. Long story short, though, we see this very strong opportunity for urban autonomous vehicles, particularly low-speed urban autonomous vehicles. I'm happy to spend too much time talking about that, but we have this great panel. I'm really looking forward to all of the questions from this audience. And thanks again for having us here.
Okay, next I'd like to introduce Tony Canasta. He is the director of the corporate ventures at a minor little small Denso. It's the kind of a automotive parts and systems supplier company. He is the international, in the international America, which is called DIAM, and it's the U.S. subsidiary of Denso. And he joined Denso in 2014 and is primarily responsible for the identification of investments in startup companies working on new technologies in the area that are strategic to their company, future product roadmap. During his brief tenure at Denso, Tony has made 5 investments, so they have money. He currently serves as the board directors for ThinCI, one of the Denso's portfolio companies, and Tony also works on their M&A, which is the merger and acquisitions group. Prior to joining Denso, Tony worked as an independent contractor, helping clients with startup technologies discovered in the Santa Clara Valley. Prior to his work as an independent contractor, Tony was the executive vice president of Ignite Group, a venture capital company based in Silicon Valley. And he has a MBA from Stanford. He's got his BA and MBA are both from Berkeley. So with that, I'd like to turn it over to Tony.
Thank you, Gary. Thank you, everybody, and I appreciate y'all attending today. Who knows who Denso is? Okay, so I don't need to go too much into that. So large tier 1 auto parts supplier worldwide. Last 2 years, we've done just over 40 billion in revenue both years. We supply discrete parts, components, modules, and work with almost all of the OEMs across the globe. By far, number 1 customer, however, is Toyota Motors. 6 years ago, we opened an office here in Silicon Valley with the express purpose of looking at external innovation. Why is that? Well, because external innovation now, startups, are really beginning to impact the auto industry. And that was never the case before, right? If you look at the 100+ years history of the automobile industry, we're a tiered, pyramid-structured industry for a reason. And the OEMs sit at top and they design things and come up with new ideas, and they throw those down to the tier 1s, companies like us, to figure out how to design it, build it, provide it to them. And then we'd throw it down to vendors underneath us to do parts that we would then build up into that system and supply to the OEM. 100 years, it worked great. Well, relatively great. Now it's not working so great anymore because we've got lots of startups that are disrupting our industry. And so that's why we started the office. I deal directly with the corporate venture group, and I lead that group, and we do investments into early stage startup companies. So typically in the Valley, we say seed to Series B. My group will invest between $1 to $4 million initially, and we'll follow on. We don't invest for a financial reason because any one given successful exit doesn't affect our bottom line. We're really in it for strategic value and relationships to try to bring these technologies forward. As Gary mentioned, we've done 5 investments in our portfolio. We've done a couple follow-on into those companies. I've got 5 active new investments I'm working on right now. And so we're kind of ramping up fairly quickly now and looking to grow the group and grow our activities. But the areas we focus on, autonomous driving, connected vehicle, cybersecurity, mobility plays. Those are all key areas to us. Outside of specifics to automotive, we also look at areas like robotics. And so those are areas that, if you're working on something in that space, it's something that's potentially interesting to us. Thanks, Gary.
All right, thanks, Tony. All right, next I'd like to introduce Kevin O'Connor. Kevin is the Assistant Director of Transportation at the City of San Jose. Kevin started with the city back in 1988 as a journeyman electrician working at the city's Intelligent Traffic Signal Systems. In 2003, Kevin was the Deputy Director of Maintenance for the San Jose's DOT, where he led over 375 people responsible for maintaining the city's public infrastructure, including paving, sidewalks, landscaping, sewer, traffic signals, roadway markings, and street lights. So if you want to complain about potholes, there's the guy, okay? Kevin is now the Assistant Director of DOT, overseeing the planning and project delivery, operations and maintenance of the city's transportation system. Kevin plays a direct role in the city's wide effort to implement a variety of innovation technologies, including vehicle announcements or advanced sensors, data and analytics, roadway lighting, and Kevin has a degree in business management from St. Mary's College. With that, Kevin.
Thank you, Gary, and good morning, everybody. Thank you for coming. It's a pleasure and privilege to be here. I'm very humbled by all of you here and those on the panel. Before I start, I want to let folks back there know that there are chairs up front. Feel free to come on up while I'm speaking. I don't think you'll miss a whole lot. So just a little bit about San Jose. We are the 10th largest city in the country. We have a little bit over 1 million people. We're the largest city in the Bay Area. And we're expected to grow by 40% in the next 20 years or so. So another 400,000 people in our city by 2040. Certainly that poses a number of challenges, especially on the transportation front. We believe that autonomous vehicles could be one of the the key driving solutions to dealing with that challenge. We certainly have aggressive goals around reducing congestion, reducing miles traveled, improving safety on our roadways, and eliminating all deaths on our roadways. But again, we are challenged by a number of things. We are a transportation agency that does tactical and operational work on our system. You heard my background. My background is in maintenance and paving roadways, and we don't have nearly adequate resources to really fully serve our transportation system. So we're challenged in a lot of ways, keeping up with the technology, what the customer preferences are and driver preferences are in our city, and really just planning and building the transportation of the future. We're interested in hearing from the industry, from anybody out there, all of you, what cities can do, what we can do specifically in San Jose to support the future of transportation, really achieving some good goals around sustainability and efficient, balanced transportation system. I'll add that we recently released an RFI, request for information, looking for ideas and possible solutions to implementing and piloting AVs in the city of San Jose, so we can start to really plan and influence the direction that AV goes in San Jose and other cities, certainly around the Bay Area.
Thanks, Kevin. Okay, next I would like to introduce Vinay Shah. He is a senior manager at Renesas. Vinay has an extensive background in connected vehicles, autonomy, and intelligent transportation systems. Currently, he leads the Silicon Valley Innovation for Advanced Research and Development for Renesas Electronics America for automated vehicles. Vinay has a successful proof of concept for autonomous level 4 driving, connected vehicles in US, China, and Japan. Prior to Renesas, Vinay worked as a vice president of product marketing and management at Arada Systems, a leader of V2X suppliers. And Vinay also has a mission is to promote the autonomous and self-driving series of vehicles and autonomous projects. So with that, Vinay.
Thank you. Thank you so much. That was really a mouthful, Gary. Thank you. Good job.
Yeah.
So, like everybody else, I'm going to steal Tony's question, for example, but who here knows Renesas? Wow, I'm quite pleasantly impressed. So Renesas is like Denso, a Japanese company. But the most interesting thing about Renesas is basically it's a conglomerate of three major semiconductor companies, Mitsubishi, Hitachi, and NEC. So we basically went ahead and cleaned the slate straight, went ahead and incorporated in April 2010. And as of today, at this point, we are a semiconductor company heterogeneous to all platforms, medical, general purpose, et cetera. 50% of the business is actually general purpose, 50% is automotive. But what's really impressive about Renesas is that we're the company you haven't heard of because we are the #1 MCU, microcontroller unit provider, in the car. So if you're driving a car, you probably have a Renesas MCU in it, okay? Basically at this point, in 2015, I think, we took this company and we said, hey, what are we gonna do with the next level of driving? What is gonna go ahead and happen? How can we build our chips to go and support autonomous driving? So a group of us, and I get credited less for this, there are people much more intelligent than me that took this to the next level, but we went ahead and started developing the car and initially going ahead and putting up what I call a smart platform, basically cameras, LiDARs, radars, and V2X. And this was the first stage of going ahead and fusing all this data together, right? And then really learning what that data was about and how we were going to go and get the car to go ahead and drive. What we did basically by the end of 2016 was put our first level 4 autonomous car on the road. It is not created by us. It is a Ford vehicle at this point, but we managed to go ahead and do that, and we're almost completing our second car at this point. So really at this point, what we're looking for from you is this participation, this feedback on how we can go ahead and continuously make our cars better, because we work with tier 1s and actually Silicon Valley OEMs to get the next level of data. So really understanding the perspective from you on your end and working with them and sharing those ideas. Thank you.
Thanks, Vinay. Okay, and our last of our panel is Lutz Eckstein, is Director and Chair of the Institute of Automotive Research at Eckstein University and Chairman of the Advisory Board of FKA, which is the parent company of the FKA Silicon Valley. He is the chairman of the Science Society of Automotive and Engineering Technology, which comprises of 33 professors in Germany, Austria, and Switzerland. Moreover, Lutz is directly involved in the strategic discussions on automated driving, as well as electric mobility within the German government. Lutz has a PhD in mechanical engineering from Stuttgart University. He has 15 years of R&D experience in the automotive industry, focused heavily on safety assurance of automated driving, level 1 and level 2 at Daimler. And he was the general manager at HMI, a humans factors at BMW. We also got to play around with Rolls Royces. Yeah, had to throw that in there. So if you need one, he's the guy to go talk to. In 2010, he was appointed at Eckstein University as chair and director of the Institute of Automotive Engineering. His field focuses on e-mobility and automated driving, in which is in combination facilitating innovation vehicle concepts. He is the inventor or co-inventor of over 150 patents, either patents or pending. So with that, let's...
Yeah, thank you very much for the kind introduction. Thank you very much for having me here as the only European guy, basically, here. So I try to make this a little bit more international, but I won't comment on the things which were mentioned here on Europe or on Washington, which were talked about earlier today. So Aachen University is the largest German technical university. We have 44,000 students. We educate more than 200 students in automotive engineering, leaving Aachen University with a master's degree. We have more than 80 PhD students. I don't like to call them students because they all have a master. They are fully blown engineers. Some of them stay with us afterwards at FKA. So FKA is an R&D service company, engineering company, you could say, which is neutral. So we work for American companies as well as for German companies, European companies, Japanese companies. So we're quite broad and neutral on that. We have a yearly turnover on the FKA side of more than $10 million only in R&D with these companies. And on the IKA side, on the university side, of course, we do a lot of publicly funded research and fundamental research. What we do in terms of automated driving is, on the one hand side, we research on technologies which we need. So we need new types of sensors. We need also X-by-wire systems in the vehicles, new types of steering systems, and so on. Then we, on the other hand side, we work also on algorithms, trajectory planning, sensor fusion, and so on, but also on methodologies. So methodologies, there's a huge demand for simulation methodologies because you need to design most of your automated vehicle in simulation in order to make it cost-effective and fast. And on the other hand side, you need methodologies in order to assure safety. So you need to combine simulation on the one hand side with testing on the test track, with testing on public roads. That's another focus of our research. What appears also very important to me are methodologies in order to understand what an attractive driver experience is and means. Because I think that e-mobility in Europe is not taking up so fast because the experience is not there. So there is no real benefit of driving electrically. Here in California with Tesla, I think the big benefit is that you show basically you are not one of these old school guys still driving your Mercedes or Audi or BMW or whatever, but you made it and you understood that the world is changing. In Norway, you have financial benefits from driving Teslas and electric vehicles, but there's no positive experience of driving electric vehicles or automated vehicles in Germany. So we try to understand and try to create methodologies how we can measure and evaluate acceptance before we really have technology. And that's, of course, not easy, and that's where driving simulators come into play. So with driving simulators, we can depict the effect of future technologies. We don't have them yet, but we can depict how automated driving could feel, how electric driving could feel in a driving simulator. So here in Silicon Valley, we have a static driving simulator environment at Prospect Silicon Valley. In Germany, back in Germany, we have two motion-based driving simulators, one high-fidelity driving simulator where a hexapod is sitting on a lateral rail with which we can depict driving on the three-lane motorway just one by one, so you won't get sick with it. And from time to time, we transform our knowledge which we gained in own research vehicles. So currently we just build a research vehicle, an electric vehicle, where you solve one big issue, which is maneuverability and parking. So of course here in the States you have plenty of room, so it's easy to turn around or to park your vehicle. But in Europe and in other places, you have the big problem to turn around. So you see the sweat on people's heads when they need to go backwards and when they need to reverse. So we build a vehicle with which you can just turn around. The car has up to 90-degree steering angle at the front wheels. So it just turns around one of the rear wheels. That's a concept which you cannot do with combustion engines. You can only do it with electric drives. So we think that if we talk about electromobility, if we talk about automated driving, we need to get away from a purely technology-focused discussion and come up with the real benefits and discuss the real benefits, find the real benefits for people, why they should choose to drive like that. Okay, thank you very much.
Thank you, Lutz. Okay, so let's start off with some conversations here. I thought I'd start, since we have two entrepreneur funding members here. I thought we'd kick off with that. So hopefully that there's some entrepreneurs out there that maybe have got some great ideas. They're off developing it in their garages. What do they do in that to take this new great idea and maybe get it funded?
Okay, I'll jump in and start out on this. So it's a good question. Are there entrepreneurs out in the audience? So is this irrelevant? Okay, we've got a couple. So we do fund startup, early stage startups. So I'm interested in seed stage companies that have an idea, maybe have a patent that's in process because they filed some IP. And, that idea is hopefully going to lead to something that's going to be spectacular and disruptive to the industry. It's a long task. I know I'm sitting up higher than you. I'm about to stand up on my soapbox, so get ready. Everybody here Warriors fan? Yeah, go Dubs. All right, go Dubs. Congrats, good job. If you talk to your average NBA player about the regular season, they'll tell you it's a grind. And you want to start a company in the auto industry, you better get ready to grind. When I make an investment, seed stage, Series A, when the money's transferred, I tell the CEO at the first board meeting, strap in. And I'm not talking about some little skinny seatbelt in the airplane. I'm talking about a 5-point F1 seatbelt because it's going to get bumpy, it's going to get rough, it's going to take 5 to 6 years. And I'm not trying to say this to discourage you, I'm trying to say this to plan for it. Because if your technology is good, we'll support you along the way. We'll try to get you in front of OEMs. We'll tell you what the specs are. We'll tell you what the testing regimen is to get done. And we'll try to get you there. And we'll give you money along the way to try to make that happen as well. But there's 2 criteria in our industry that will never disappear. And probably everybody here on the panel would agree with it, which is safety and performance. And safety comes above performance. Because we're not going to build something that's going to put you, your kids, your parents at risk. And we're a tier-structured, pyramid-structured organization, industry still for that reason. Because things get tested on the way up to the OEM, and that testing doesn't go away. So while we're here talking about the pace of innovation, looks like it's really rapidly increasing in the industry, yeah, there's hundreds of thousands of startups now. Go to Israel last month, and I went to an event where there were 200 startups focused on transportation. So yeah, the pace of innovation might be increasing, but the pace of deployment is not going to match that for the very reason that it has to perform and it has to be safe. And we can't step away from that, and we're never going to step away from that. That's our core mission to what we do for our end customer, the OEM, and that's their core mission that they promise you when you buy one of their vehicles and get in it. Doesn't matter if it's a small vehicle or a big vehicle. It's got to perform the way you want, and it's got to be safe. So I encourage you, great ideas, bring them. We'd love to hear them. If we fund you, we're going to tell you, here's how you get that 5 years, and here's how we work to get it done. And so, don't want to be discouraging, but at the same time, it's a little bit dose of reality. Okay,
So,
should I leave now?
Yeah, I think you're all done. Thank you
I'm all
very
finished.
much.
All right.
We'll see you next week. So I think our answers would significantly overlap, so maybe I'll just add a slightly different perspective, although I agree 100% with what Tony just said. We did about a dozen investments in the last year. Some of those were equity investments, venture capital. Some of them weren't. Some of them were engineering funding or vehicle supply or other kind of creative ways of supporting a startup. I say that because cash is only kind of one tool in our toolbox, right? We have several other tools. We make and sell vehicles in 200 countries, as I said earlier. Maybe cash is amongst the least valuable tools in our toolbox if you're an early stage startup and want to deploy globally. But as a venture capitalist, as somebody who goes to those board meetings and says some version of strap in, right? My recommendation would be this, and this is based on the deals that we've seen in the last 12 or 24 months, right? Most seed and Series A funding deals now involve a variety of partners. Corporate venture capital, both of us are included in that group, represent about 1/3 of all deals. 1/3 of the deal size, right? Not 1/3 of all deals. We tend not to do deals alone. We certainly have the ability to, and if it's really seed stage or really early stage, we may say, look, we're acting alone and doing it. But if it's a Series A company and you're raising kind of what's in the middle of the bell curve of a Series A, right? Tony and I are likely to call each other and say, let's do this together, right? Along with traditional venture capitalists, along with angel investors who may have been supportive earlier, right? And so it's about you as an entrepreneur building a consortium, building a group of people you want to work with, right? Do you want Tony or me in your boardroom? Yes or no? The answer, no, right? It's like, definitely not, right? And so it's a two-way interview process and building a consortium. And this is part of the reason it takes some time to do this, is you want to build a very strong consortium. And so maybe I'll just leave it at that. The best way to get started, my recommendation would be to find anybody roughly in the industry of funding startups or supporting startups, and start with an informal cup of coffee and say, what's the trend like? What have you heard in the last 6 months? What's a recommendation for somebody in my position? Who should I talk to? Often the deals get done that way more than they do by sending a business plan into a website or something. So, Sufficient coverage?
All right, good enough.
Good. Thank you.
Thank you.
Happy to continue.
All right, let me also, I got a third. So let me start with, maybe go to a different route, is, the state of California has kind of the toughest DMV rules. Maybe we could talk a little bit about, how do we see the, government, either impacting or improving or reducing our chances of getting autonomous vehicles going here, at least level 3s and above, faster or slower?
Yeah, I'll take that question. So I'm wondering how many people in here are interested, have a stake, or concerned about DMV regulations? Okay, all right, so a lot of folks, yeah. So, I'm just to come out in front and say that I think we're, at this point, fairly pleased the direction they're going. We'd like to see them happen faster. We've been told by the DMV, expect something by the end of the year. Certainly, if that happens, I think we would be pleased with that. But kind of on all major points, we're feeling, we're in a pretty good place. And San Jose is working with the largest cities in California kind of collectively to provide input and write letters and work with the DMV on the direction of the regs. We're very supportive of having the DMV take the lead in regulations and not having a patchwork regulation framework where every city has a different set of rules and regulations or permits required. We really want the state to handle that. The direction that the state is moving toward is allowing cities to opt out of allowing AVs in their local jurisdiction rather than having them require approval of that to happen. So we're supportive of that. In fact, San Jose, we don't want to restrict the use of AVs. We really want to push the envelope on allowing them to test and operate in San Jose. Other things that we're interested in are related to data and data sharing and reporting. We want to know what you're seeing on the roadways as you're testing and piloting and operating vehicles. Where are the vehicles traveling? How far are they going? How long is it taking? How many passengers are with you? Are there disengagements? Are there collisions? Are there problems that you're seeing on our roadways that we could fix and adjust to make it safer and more efficient for you to operate? So we're really important in seeing some data sharing. Certainly we have a concern around safety of the vehicles, and it's good to hear that the industry is concerned about that as well. We see AVs as a solution to our traffic safety problems. And San Jose, relatively is a safe city to drive in. We have half the national average of severe injuries and crashes in San Jose, but that's still not good enough. People still die on our roadways. So we're really interested in making sure that the vehicles that are operating and testing in the San Jose are safe. And we're hoping that there's some sort of testing or certification process to prove that before the vehicle hits the roadway. The other thing is our police enforcement officers, our law enforcement officers. How do they interact with an AV if something happens, if there is a crash or something occurs to the vehicle, giving the tools and the information for officers to be able to do that. At this point, the regulations aren't requiring that companies provide that information proactively to us, that it's available to us, but we think we need to know that up front and be able to respond to that. So those are some of the things that we're working on. I'm more interested in hearing from you all about the things that you're concerned about or that the direction you want to see that go. So maybe when the opportunity arises, Gary, I can take some questions on that.
All right. Thank you. Maybe we could also kind of talk a little bit about connected vehicles and, how are vehicles, connected? Should they be 4G, 5G? What is 5G? I guess most of us know what that is, sort of, kind of. Connected, DSRC, how important is connected vehicles with autonomous?
Yeah, I'll go and take that. So just a question for the audience. Do you know how many fatalities there are a year according? What? About 40,000. Brian? 40,000? All right, wonderful. Just checking. All right, just making sure I confirm. So as far as connected vehicles are concerned, and the reason I'm taking this is Renesas works both with connected and automated vehicles. And there's a consistent debate on saying, okay, we have all the sensors. So I want you to think about your car as yourself, right? Your ears, your eyes, and everything like that. So I call that me around me, okay? But the interesting thing about connected vehicles is I don't know what the person on the right is doing at this point, and I might go and collide with him, right? So there's the around concept, and then there's the surround concept, okay? That's where V2V becomes very, very important. We did some data analytics on a public crash that I won't mention the name of the company or whatever it is at this point, on an autonomous vehicle that hit another car. It was an impact, call it a side impact, forward collision impact. I'll be very general about that. But what we backed out is we said, hey, the car had LiDAR, it had radar, and it had camera. Okay, what it did not have is it didn't have V2X. And we went ahead and back analyzed the data, and we would have added an extra 6.8 seconds, assuming the car would have traveled about 37 miles per hour, which it did approximately, okay? So my point is connected vehicle is just as, or if not more important than automated vehicles, because it's happening now, right? The mandate is happening now. The other piece is whether you scale with DSRC or 4G or 5G. Does anybody know the difference between 5G and DSRC? Well, go ahead.
Yeah. So DSRC is basically based on 5.9 gigahertz. It's an automotive, you could say it's an automotive Wi-Fi standard. To me, what I learned from US DOT is that US DOT is very much in favor of DSRC, not because of its performance, but they don't want to leave traffic control up to private partners like the telecom industry. The telecom 5G, if you go for 5G, of course, it's much more performant. If you talk to companies, they are targeting at transforming big amounts of data with 1 millisecond delay. So in terms of performance, it's way beyond DSRC. So that's not really the point. From my perspective, it's not an either or. So what I like to think is, how can we combine both? Because if you only would rely on one channel of communication, you can't do any safety relevant thing. So today, the complete automotive industry is on a track where they say, our cars need to be able to drive automatically without connectivity. Of course, they want to benefit from it, but in a safety-related incident, they must not rely on connectivity, because you might not have connectivity, because there might be disturbances, whatever, failures. So you cannot brake in, do an emergency braking, which has been asked for via connectivity. So it doesn't work. So in the end, I think we need to combine both. Nevertheless, it's two dimensions. We have connectivity, and I fully agree that with connectivity, deploying connectivity, we can save more lives quicker than with automation, because automation is not as fast. We have more legal issues to solve in terms of automation, more technology issues to solve. So if we talk about improving road safety, then I think we should put a strong emphasis on connectivity, and automation in various levels will take place. We should not forget level 2 automation, so what we already can buy today, because here we have huge numbers. We have many cars, whereas if we talk about level 4 automation, we on the one hand side see a few shuttles around that will help us to improve public transport. We will see maybe a few very high-priced premium cars which will drive level 4 automated, but they won't save many lives. So the lives will be saved by mass products and by technologies like connectivity. Having said that, of course, the big question we always run into is how can cities afford to build up this infrastructure? And here I would like to propose something new which tries to copy a little bit what we see when it comes to selling licenses for the mobile phone industry. So we would need to create, or simply deploying DSRC technology will not be interesting for anybody. It's only expensive, of course, for governments. It's important for emergency cases and so on. But if you would say, well, what we deploy here in terms of infrastructure is not only a DSRC element, but it's combining different sensor technologies where you can establish a platform, basically a platform which delivers you in real time all information which is relevant for traffic. So I think such a knowledge on traffic in a city could be interesting from a business perspective for many different businesses. So you as a city could come into a row where you say, I allow you to deploy this infrastructure at my intersections, yeah, and I want you to deliver these and that data to me, yeah, that's the deal. I want you to pay for it, that you do it, and you, of course, you have the ability to make business with this data, yeah. So I think we should go away from thinking this DSRC topic too small, yeah. I think we should extend it a little bit. Yeah.
Can I just add one more thing? The difference between DSRC and 5G. 5G isn't here yet. That's the difference.
Well, I wouldn't. Who would vote that DSRC is? Okay, and then kind of like maybe one last before we'll open it up to the audience, and anybody can kind of throw in this, but automotive manufacturers or anybody putting an AV on the car in the road really needs to ensure that it's safe. It really has to probably go beyond that. Maybe the panel could talk a little bit about, how do we go and, what's the responsibility of the automakers and the component providers to provide us a really safe product?
Yeah, so maybe I'll get started. Safety is an interesting issue, especially in robotics. We kind of have we as human beings, I think, have a preconceived notion that safety equals perfection, right? But just earlier, you asked, how many people died on the roads, right? If we save one life off that number, right, we've improved the situation, certainly, right, by saving one life. If it's 39,999 instead of 40,000, right, and that person's a relative of mine, I care a lot about that one life, right? And so, what's the benchmark we're using? Typically, the benchmark defaults to perfection, right? And that's like saying autonomous vehicles will never have accidents, right? That's an impossible standard. Right? You can't think of a robotic system that has perfection, right? But if we say, look, our standard is to do better than human drivers, right? To be quicker in making decisions, to be more aware of the surroundings, to be better reactive, to communicate with the driver next to me better than I can currently do, right? If that's our standard, then we're already making great progress against that standard, right? So I think we have to define safety carefully. Right? Of course, everybody will agree that safety is the #1 priority, right? Making vehicles that are safe, that perform well, that are enjoyable experiences, that we want to spend time with and in. Yeah, absolutely, right? I think many of our companies share those goals, and safety is almost always #1 on that list. But I'll just keep going back to this point about how we define safety, especially related to the earlier discussion about technology choices. Is it A or B? Well, it's likely both. We find ourselves kind of demarcating various use cases and saying, look, in dense urban environments, the situation is very different than open highway. Right? If I'm driving at 70 miles an hour, exactly the speed limit in open country in Montana or something, right? That's a very different circumstance for autonomous vehicles. It's not so challenging. There are vehicles that can do that, including the ones you've built, that can do that quite reliably today, right? But if I'm saying I'm in the middle of San Jose and I'm doing 12 miles an hour and, city buses are trying to merge into my lane and we have bicyclists and construction workers and a bunch of other things in the surroundings, that's a very different circumstance. But also, the ability to adapt infrastructure in downtown San Jose is dramatically different than rural Montana, rural Iowa, or someplace in the middle of the country, right? So it's hard to say one size fits all in terms of technology as well, and that we as Yamaha are saying, look, the dense urban environment is a good place for us to start, particularly because of things like infrastructure, the speed at which the vehicles operate. So that's my 2 cents. Tony.
I'll jump in quickly. Just say, if you're really thinking about autonomous driving level 5, I can crack a beer, drink it, go to sleep, and the car's going to get me there. It's a jigsaw puzzle. That's why you have this panel up here, because there's lots of things that have to come together. And don't just look at an OEM building an autonomous car, because we can kind of do that, and we'll get you there on the technology side. But the government's got to do some things. Do you want that autonomous car to be hacked? Well, really, no? Okay, well, then we got to have cybersecurity in there. That's not perfected yet. There's state level regulation, there's federal regulation. There's so much things that have to come together to achieve that vision. And then you got to layer on the question, which is around safety. I agree with the mission, and as a company, we say, it's our #1 priority, but we can't guarantee that an autonomous vehicle is going to have every single corner case figured out that you encounter in your daily drives, or if you put 100,000 miles on a vehicle, you're going to go through some really weird situations. And if you're on the back roads of Montana in the winter and a moose is standing in the middle of the road, and your autonomous vehicle is trying to figure out is it going to move or not, I'm sitting there screaming, it's a moose, hit the brakes. Those corner cases, add a single mile per hour of speed, and it changes the decision. So we just undertook at Denso an R&D project that started in April about, and let's wrap your head around this one, how do you quality guarantee an AI system? So how can I tell Toyota Motors, the system's got AI in it, but we guarantee it's going to work the way it's supposed to work? I don't know. We don't know. That's why we're doing a research project on it. And obviously it ties into simulations and all that kind of stuff. And those work to a certain degree, but if you're a Toyota Motors, do you really trust that simulation to basically mimic what's going to happen in real life? So there's, it's a jigsaw puzzle, and there's lots of pieces that have to come together to make the picture look perfect for us.
Just to add to what Tony said, so Renesas' core competency is functional safety, right? So we focus on what you call ASIL rated chips. So currently our rating is ASIL B, if you would. The way we approach safety right now, like you said, there's so many case scenarios that it would be very difficult to ascertain when that person's going to have that accident. Should that person go ahead and brake to kill 2 kids on the left or 2 kids on the right, or kill himself in the middle of the tree? That's general liability, and that's an opening of a can of worms that we can all have subjective opinions to, right? So that's all debatable. I think our approach for functional safety is really that redundancy, that we would have as much fail-safe operations as we could in a car, because we know at this point that the liability, should the automaker really go ahead and be liable if it's a checkmate solution? I don't know. That's debatable. There's a lot of government regulation that needs to happen as well and all that. But our approach to functional safety is really, when we do our chips, we always have redundant platforms to go and help protect it. But it's not 100% fail-safe. That's for sure.
Yeah, thank you. So the first thing I would like to state here, being now a university professor, but having worked for the automotive industry, is there's no company out there who's not taking safety seriously. They are not self-murdering themselves. So there are too many lawyers out there, and there is something like social responsibility for every car manufacturer. So safety is ultimate for everybody. What we try to bring up, and what we now follow in a German national project, it's called Pegasus. The project is an idea we called, it's a continuous circle of corner cases or relevant situations. So we say we can learn from traffic accidents, of course, but we can also learn from large-scale field operational tests, but we can also learn from from testing which car companies and suppliers do anyhow, for instance, in order to check whether their suspension system or their drivetrain is working properly. And moreover, we try to pick up concepts which Tesla is already doing. So we try to also learn from driving from normal drivers out there who are willing to share their data. And all the information or from these data, we try to extract relevant situations into and store them into a database. And this database, the knowledge in this database is shared. It's in Germany, it's shared between the road authorities on the one hand side and the automotive industry and also the universities. And we now are in a discussion first, to close this circle is, of course, then you can extract from these database the relevant situations and can first confront your automated driving system with these, let's say, 4,675 critical situations in simulation. Then you find out, okay, there are 25 situations where something happens what should not happen. So you take them to the driving simulator, and as experts, you can experience what is going wrong there, and then you can try to fix it. And finally, you may know that your system has maybe some problems with a certain type of situation, so you test them outside on the real road in order to be sure that the whole thing works. This concept we now are in discussions with on federal level, whether we can bring this concept here also to the United States. In order to make sure that the automotive industry has globally a similar scheme, basically, how they can assure safety of their systems. So that's certainly, I think, a concept which could work. We need to still to prove that. On the other hand side, you of course need to be aware that accidents will happen, and we will have discussions like with airbags, whether it is societal acceptable to have certain accidents, knowing on the other hand side that you save many lives by automated driving. So we will run into the trouble that we need to balance somewhere. Today, looking at airbags, it is accepted. So it's known that every year, especially children die. They are killed by airbags in accidents, but this is socially accepted because we know that there are so many thousand lives who are saved due to airbags.
Okay, with that, I'd like to turn questions over to the audience. Joan, back there. He was the first one.
This question is for Amish, Tony, or Vinay. Kevin and his city, they have a Vision Zero plan for zero deaths, and this is a very important international movement, particularly in our mega cities, to try to eliminate fatalities. Of those 40,000 fatalities in the U.S., about 8,000 of those are pedestrians, and that's the highest rate of increase of any traveler. I haven't heard much today about what your industries are doing to connect B2P or B2B and getting a focus on eliminating pedestrian deaths.
All right, so you're asking a question about how Denso as a company feels about trying to solve the pedestrian death problem.
Well, what I'm hearing is a lot about connected vehicles. How are we connecting to the pedestrian with the devices that we're putting in our cars or that pedestrians might be wearing?
Okay, so we talk about V to X, right? So we've talked about V to V here at the panel, but really it's a V to X issue, right? So, and the X could be anything. I don't want to run over your dog in the street, and your dog might have a tag on it that's be able to transmit information. So why the possibility is happening, and this is why I referred to it earlier in my comments. It's a jigsaw puzzle, and all these pieces have to sort of come together to solve the different layers of problems. And so you're talking about a layer of that problem, which is pedestrian detection. Well, so we're looking at LiDAR technologies and advanced radar technologies that can, easily identify objects in the road or objects in the vision of the vehicle, and then be able to have the vehicle make a decision around what I need to do to avoid that particular obstacle, whether it's an animal, whether it's a person, whether it's a child on riding a scooter around. And so, the technology is rapidly advancing to get there. The implications of that, there's ripple effects. So let's say you're driving in a car that's got that capability. Your car thinks this child's gonna bolt out in the middle of the street. You slam on the brakes. The car behind you doesn't have that capability because they're driving the car. It's my dad who's 87 years old. He runs right into you. It's his fault for not following, but he can't react nearly as fast as that computer could react. And he's going to say, and if the child does not go out into the middle of the street, you've just slammed on the brakes for no reason and caused an accident and potentially a death behind you, right? Depending on how bad the accident is. So that's just the jigsaw, all these different layers and ripple effects we're trying to figure out. And again, that's why governments have to be involved in these decisions. Society, what's our culture around implementing this? When it's not going to be implemented, one day we're not going to all have autonomous vehicles, right? And so how do you deal with that particular scenario? And that's something that's sort of outside the bounds of what we can do. We can deliver you the technology to make that problem kind of go away, but there's other problems that might arise from that implementation.
From a overview, technical overview, we ran a proof of concept that actually used camera perception, so computer vision, let's just go and call it that. Used a camera, and this is a proof of concept that we went ahead and ran with a partner city. And we used the camera taking a photograph of an object, call it a deer, a person, and then basically going ahead and converting it into what you call a basic safety message that went through what you call a roadside unit that informed the car that, hey, there was a pedestrian going to be crossing the road, potentially on a green light or red light. So these proof of concepts are being developed at this point. So we are going ahead and addressing the V2P issue from a Renesas perspective on a platform level. Again, we're a chip company, so we'll provide the platforms to like a tier one, and then the tier ones will package it for the OEMs. But these are the things that we're looking at right now.
Maybe one short comment on that. The positive thing is that perception, this camera perception is already better than the human. And the reaction, of course, of a technical system is faster than the human. So I think things are going to get better. And the next thing, of course, is to turn the thing around that also people carrying a smartphone, that they are being informed that the car is approaching. So there are also projects looking at that. Yeah, yeah.
All right, next question.
Director, Hybrid Electric Vehicle Laboratory at South State University. The theme of this session is challenges, barriers facing AV deployment. So my question in particular to Amish, Tony, and Vinay is, in your opinion, what is one single challenge and what is the solution you could provide?
Maybe we can just go down the line. I'll get started.
Yeah,
thanks, Tony. Okay, so I'll say the one single challenge actually builds on the previous question, right? It's coordination, right? If you want to save pedestrian lives, right, you can do many things to solve it, including improving vehicles, but not just improving vehicles, right? If you have an intersection where people get hit, stop signs, stoplights, pedestrian overpasses, you can think of many other solutions to save lives at a given intersection, apart from just the vehicle, right? Our perspective, our bias, my bias is as a vehicle maker, fine. Right? But there are other solutions. I think coordination is by far the biggest challenge. Somebody used, Tony, I think you used jigsaw puzzle earlier, right? There are all these pieces that we have to bring together. We see our role as one of those coordinators, right, to bring the pieces together. There has to be sensors in the infrastructure. Really quick example. If you have 50 autonomous vehicles in a 2 square mile radius, right, do you put 6 LiDAR, 2 radar, and a dozen cameras on each vehicle? Or do you put sensors in each lamppost? So all the vehicles can share that sensor burden, right? It's not an obvious question or an obvious answer, right? But it's likely more than just one and more than just the vehicle maker's perspective. So my simple answer to you is coordination.
Yes. I know some of you will have a slightly slanted answer, but I'm wondering how much, oh, sorry. Oh, thanks. I know some of you will have a slightly slanted answer based on who you work for, but how much are you looking at, this is coming from the OEMs and will be built in, and how much might actually be aftermarket that we put on vehicles that are already in service?
Yeah, so Denso has a very healthy aftermarket business, and we've looked at the aftermarket for technologies that could be used to enable, autonomy. It's an expensive proposition to the customer right now, and we're not sure that there's an appetite to install all that's required to bring those aftermarket technologies to a point of usefulness for the driver, right? I mean, if you're going to change out the electronics of the vehicle and you're willing to do that and put in Renaissance latest stuff, yeah, then you might be able to hook up a LiDAR or two around your vehicle aftermarket. You might be able to put some radar around aftermarket, but you're almost better off just saying, I'm gonna wait to the next cycle of when I buy my new car.
Maybe a slightly different answer. We have a project called Motobot, M-O-T-O-B-O-T. You can look it up on, I'd suggest, YouTube. The concept is retrofittable autonomy, right? And so we're developing a humanoid robot that can sit in vehicles. Realize every vehicle ever designed has a human interface that somebody your size and weight can operate, right? It doesn't matter if it's a military tank or a 747 or a Wave Runner or something else. They're all designed for human beings to operate. So we have this concept of retrofittable autonomy. We started with the hardest vehicle that we could think of, which is a motorcycle. It's been going on for 2 years. At the end of this year, it'll beat our best factory rider around a racetrack autonomously. It's an ongoing project. As I said, look on YouTube. The first applications of that will be retrofitting things like farming tractors, right? It won't be on city streets where you need the LiDAR and the radar. It'll be going up and down rows for 10 hours a day, right? Where it's a fairly simple application. The safety concerns are minimized, right? And so that Motobot project will be deployed as retrofittable autonomy, but probably not on public streets tomorrow.
Let me just add a business perspective to that question. So, so first we talked about the expensive proposition, right? And consumers, Tony's right. I mean, my guess is he's right in the sense that people would not want to go ahead and retrofit and pay for them, right? But there are businesses like, for example, I'll take this is again, another proof of concept I can say with a customer and an insurance agent that said, hey, we will supply the usage, if we can get data on how the driver goes ahead and drives, we will supply aftermarket DSRC devices. So where the consumer doesn't have to go ahead and pay, it's kind of like the whole Verizon cell phone thing, right? Hey, let me go and give you the data at this point, but we're going to know exactly what's going on. So there are opportunities like that people are looking at as well. And I should say less at this point because there's more. There you go.
Yeah, I think we need to distinguish between different levels of automation. So if we talk about driver assistance systems, level 1, level 2, this can be an option, but if we go for level 4, then it becomes rather difficult because also the actuators of the vehicle need to be fail operational, and they aren't. Yeah? So you cannot fit everything as an aftermarket product. So I would differentiate between different automation levels, level 1, level 2, yeah, good option, level 3, difficult, level 4, even more difficult.
So sustainability and autonomous vehicles are not necessarily synonymous. I mean, the dystopian view of AVs is such that you have a bunch of individually owned level 5 AVs roaming around burning petrol, waiting for their driver or owner to request that they come and retrieve them. And so I'm wondering if you guys are looking at the integration of AVs and or connected vehicle technology along with things like efficiency and electric drivetrain integration, because ideally we want shared autonomous electrified vehicles in order to net pollution reduction, resource conservation versus a bunch of inefficient combustion engine vehicles that have all these connectivity options on them. So I was wondering if you could give some perspectives about looking at autonomy and electrification together and to what extent you guys are examining that as part of either business development or just policy development or research and development as well.
Maybe I'll get started. We're doing exactly that, right? We're viewing are wider scale deployments of autonomous vehicles to be urban, electric, and shared. Right? If we have the equivalent of a self-driving Uber, we don't solve the real estate problem of a car. Right? It still takes the same parking spot. It still takes the same square footage on the road. That means we don't really change the traffic congestion problem noticeably, right? We change it in terms of the flow of traffic perhaps, but not in terms of the volume of traffic, right? Other factors like that. So we're seeing our approach more as an extension of public transport than it is of individual ownership cars, right? In fact, the vision that I'm proposing is that we don't sell our vehicles, right? They're not available for sale in this context, right? They're only sold as fleets, and they're only done in collaboration with municipalities, right? For exactly the reasons you described.
So I'd say, we're a large tier one. We don't do a whole lot in EV yet. We don't sniff an order unless it's 500,000 units a year. So you want to help solve that problem? Everybody in here start buying EVs. It's an inflection problem, right? It's an economics problem. So we'll get there. And unfortunately the U.S. jumping into fracking, and getting oil a different way and driving down the price has really hurt the inflection point of EV. And the low gas prices over the last 5 years, in our internal estimates, has pushed out our view on the inflection point for EV when we start jumping into it as a tier one very aggressively. I think you'll start seeing that happen in the next 5 years more and more, and hopefully Tesla's Model 3 will help with that, and a lot of the other automakers are starting to look at EV and trying to get to different models within their stack of models to have electrification. We're not necessarily of the view that you won't own an autonomous EV vehicle. We think ownership goes down, but you'll probably have one, and you'll probably use car sharing and ride sharing quite a bit to balance all that out. So
just on a kind of policy level, certainly San Jose is working with other cities and entities on the national and state level to really encourage the development of shared use electric vehicles. Kind of more closer to home, though, with the RFI that we just released, we outlined kind of the key goals for us in the transportation realm, which is around reducing vehicle miles traveled, reducing congestion through shared use electric vehicles. And I think as we start getting the ideas back from the industry about what might be possible in terms of testing in San Jose, we're going to look closely at those ones that are shared use electric applications, and try to because that's what we're interested in working with. And not that we won't take other ideas, but certainly if depending on the volume and the quality of the concepts that come forward, and our ability to really select and choose which ones we think are most beneficial, that's the direction we want to go.
Okay, last question. I think we're getting to the end.
last one, there we go. Oh, get the mic down there. Pass it down the road. Thank you.
So in regards to artificial intelligence, you mentioned that we're on par with visual recognition is on par with humans, but really one of the maybe areas that we're not quite there yet is on the cognitive side and being able to have that decision engine. And we talked about a bit earlier about, Tony, you mentioned looking towards standardization of that artificial intelligence. One of the things I see as sort of a glaring elephant in the room is the competition between companies and that intellectual property of the engine itself. Maybe you can expound on ways that how, as far as the artificial intelligence that's owned by each company, or the engine behind it, how could that maybe be shared and to allow for the greater good?
Mm-hmm. Yeah, that's a difficult point because from an economical point, everybody sees big money in artificial intelligence. Companies invest huge amounts of money, billions of dollars. So I think I see a few points where companies are willing to share. One is basically the question of the reference. How good do we need to get? That's one point where a shared database will happen, I think. Then in terms of training data, there will be more and more platforms. We heard it from Prospect Silicon Valley. There are other platforms out there where raw data can be taken and used for training. But in terms of artificial intelligence, which is inside the vehicle, I'm a little bit curious. Again, here's a chance for cities. So I think we should also have a city brain. Yeah? So a brain in the city which knows this is an intersection where I have problems on a regular basis because here's a school and from time to time pupils pour out of this school and then I have these trucks coming from company X driving to there and to store this knowledge basically in a city database where we have a collective traffic knowledge basically, which is of course caused by or generated by artificial intelligence using all the data which is available or which could be available. So I see in the public space, I see a good chance to do that, but not inside the vehicle. I think this is very much dominated by competition.
So just one question to you as far as the AI is concerned, right? So what we do is, and I'll just give you an example of a vision chip that we do. We've opened up the platform where we're encouraging developers, startups to go ahead and develop that platform and maybe potentially go and share it within our ecosystem to go ahead and build that from academia, right? So if you take a Mobileye example at this point, they provide a wonderful solution, but it's all black box. It means you can't go ahead and configure it. At Renesas, our platforms have been, hey, let's invite the ecosystem in. Let's see if we can go ahead and share it forward.
It's an economics issue. So, you know, we push steel, right? The car makers push steel. Where's the value of that 5-10 years from now? So the value is exactly what you're describing. So that's why it's hard to share. Because if you come up with better algorithms that lead to a better decision matrix, that lead to a safer autonomous vehicle, there's value in that. It's the same thing in cybersecurity, right? If you figure out that problem, you can make it unhackable. And by the way, in the history of computing, we're the one industry that has to be unhackable because we can't afford the cost of getting having your car hacked. So if you figure that out, it's highly, highly valuable. And that's why it's hard to share. It's hard to convince that. So it's the same thing with the city brains. I'd love to have city brains. Some startup may figure that out, and they'll be worth billions of dollars.
Yeah, I'm trying to count in my head. I think we have 4 investments in our AI right now, and I led 3 of them. One is an internal effort. It's by just that description, right? We're fostering competition, right? These, I can't think of a single example in the automotive industry of standardization really kind of taking off, right? Our cars have different fuel caps or different charging ports. Right, and if you drive a Honda or an Audi, right, there's very little standard between those two, right? Already, right, and those are mass deployed, mass market things. It's very hard to imagine the scenario where there's that shared kind of AI core engine, right? It's maybe the secret sauce of the future, right? Yeah.
Okay, with that, I would like to close off and appreciate the group here.